If you have a concern or a technical issue, please use the chat function or send an email to iteea@iteea.org. If you'd like to make the screen larger or smaller, use the plus or minus symbol at the top center of the screen. To make it full screen, use the diagonal double arrow. For questions for our presenters, you can submit a chat comment, and we encourage you to do that, or email kdelapaz@iteea.org. Questions will be addressed in the order they're received during the Q&A portion of the webinar. Please note that there will be a slight break in the voice feed between transitions. So today we have Dr. Ken Roy and Dr. Tyler Love presenting on Makerspaces, Fab Labs, and STEM Labs. These spaces are becoming more common in schools and community centers. These instructional spaces that were traditionally reserved for technology and engineering laboratories are now being found in libraries, media centers, hybrid classroom labs, and other spaces. This poses a number of risks because the amalgam of hazardous tools, equipment, and chemicals inherent within these instructional spaces. STEM Laboratory Safety Specialist Dr. Ken Roy and Dr. Tyler Love will answer safety questions and discuss content from their new book, Safer Makerspaces, Fab Labs, and STEM Labs, a Collaborative Guide. Topics to be discussed include a brief overview of legal issues and instructors' duties, more engaging methods for teaching safely, required safety controls, a broad overview of some critical biological, chemical, and physical safety hazards, the planning and renovation process, recommended areas and equipment within a makerspace or lab, and examples of makerspace and lab designs. So at this time, I will hand it over to Dr. Roy and Dr. Love.
Thank you, Jenny. I think, do I have rights to share screen?
Just 1 second, that's coming your way right now.
I want to first thank everyone that's joining today, taking time to learn about Makerspaces and Fab Labs and STEM Labs and the safety components that are part of that. What I'm going to do is I'm going to share the PowerPoint slides. So Jenny, if there's any questions that are typed in the chat box, just let me know as we go along.
Okay, I'll do that. Thank you.
Okay, can you see is it just the PowerPoint slide now?
I don't see it yet. If you go up to the top and click on share and then share your screen, then we should be able to see it. I'll let you know when I'm able to see it. There we go. Okay.
I can see just PowerPoint slides?
Yes.
Okay. So this is a picture from one of the insides of our buildings here at the University of Maryland Eastern Shore, and I thought this was a good picture. This is in our facilities complex, and obviously I think safety is a big component not only in our schools but also in our workplace, and building safer habits within the schools translates to the workplace. So this is an example of safety translating over to the workplace here, and this is painted on their wall in the building. It says, "Think safety begins with you." Like I mentioned, I am Associate Professor at the University of Maryland Eastern Shore. I currently serve as Safety Editor for ITEEA, and I'm on the National Science Teachers Association Safety Advisory Board with Dr. Roy and a number of other people from across the country. And some of the things that that board includes is we create white papers and different safety literature that is published throughout the year for Safer Labs. And that's our program's webpage at the bottom, which has some information about our Tech Ed program.
Yeah, I also want to thank the ITEEA for the opportunity to spend this time with the participants to really take a look, though a short amount of time, into safer makerspaces, Fab Labs, and STEM Labs. I just want to point out, notice how we use the term safer, not safe. they need to know right up front, you can't make it safe. You can only make it safer. Well, how do you make it safer? Well, one of the ways to make it safer, of course, is through the items that we're going to be discussing today. So hopefully that will be helpful for all the participants. I'm on staff at the Glastonbury Public Schools in Connecticut. I'm Director of Environmental Health and Chemical Safety. I serve as the Safety Compliance Officer. I'm also the Chemical Hygiene Officer. In my other life, I have been a chemistry and physics teacher for about 35 years, also the K-12 Director of Science for Glastonbury Public Schools. I also have a private safety practice. I own the company National Safety Consultants, LLC. I'm a trained authorized OSHA instructor. My main client is the National Science Teachers Association, where I serve as the Chief Science Safety Compliance Advisor, also their Chief Blogger and author on a number of publications. I'm a syndicated safety columnist. Some of my columns go worldwide. I would urge participants to join in on the NSTA Safety blog, and the address is there. That's free of charge. If you have any questions on safety, be they science, STEM, Fab Labs, Makerspaces, that's a place where you can go, and I personally do address those questions or take a look at issues. The other thing is on Twitter. I tweet 5 days a week, safety information. These are on accidents that are happening, all the latest legal safety standards, better professional practices, which can be very helpful for people out there, certainly in the field.
Okay, so one of the things is with our presentations, we've done a number through NSTA, ITEEA, and a number of other organizations, but there's always a disclaimer. And basically what the disclaimer says is that you want to make sure you seek advice from your school's legal counsel and you understand federal and especially state and local policies. So the policies in, say, North Carolina may be different than the policies up here in Maryland. So you want to make sure that you understand and know those policies for your state, but also as well as your locality. So a quick outline of session. First, we're going to talk a little bit about what are Makerspaces and STEM labs and Fab labs, what's the difference between them, what are some safety standards and safer practices. We'll talk about the planning building process and what that looks like if you're building or renovating a facility. Areas in a makerspace and lab, what types of areas or instructional spaces would be helpful to include. And then we'll share some examples of makerspaces and labs that are out there that we found to be pretty good facilities. And lastly, we'll talk about some free safety resources for schools and then answer questions.
I always try to include this in every safety seminar that I do. If you take a look at science, you can't make this stuff up. I mean, it's unbelievable. This actually was on the second floor overlooking the pool. And I think you can see it says, caution, please be aware that the balcony is not on the ground level. And really the bottom line here is don't assume when it comes to safety. I'll give you one example. I was interacting, I have to, part of my job with NSTA is to approve if you're doing a presentation, make sure all the safety compliance pieces are in place. And I had an individual that said they were using safety glasses, and I said, well, not really. I said, when you're dealing with hazardous chemicals, you really need to use safety goggles. And this person, who has many, many years of experience, emails me back and said, well, that's what I said. I said, safety glasses. And I said, no, you need goggles. The person did not know that there was a difference between the two. So again, you just can never assume. Obviously, with safety glasses, if there are solid hazards, that's fine. But you never use safety glasses when you're dealing with liquid hazards. This is our overview of our new book, which again, you all hopefully will become familiar with. And it's quite comprehensive. Just very quickly, the chapters, Introduction to Makerspaces and Labs, safety codes, standards, of which there are many. What is the teacher's liability? What is the school's liability? better practices. These are better professional practices. In other words, what are some of the strategies you need to use to make it safer? Again, you can't make it safe. Safety engineering control. What is an engineering control? What kind of engineering controls do I need to make it safer? Do I need a specific type of ventilation, for example? Do I need eye wash? Do I need different types of equipment, fire extinguishers, and the like? General safety. There are 3 levels of categories of hazards, and these, of course, what we take a look at are the biological or biotech hazards, chemical hazards, and physical hazards. First aid or first responder, whichever you want to call it. A very important part of this book is the planning process. In other words, let's say you're either going to renovate or you're going to build from scratch one of these types of labs. What do you need to do? What's the step-by-step process? And the bottom line here is, remember, once it's built, you're going to live with it for a very long time. So you want to make sure that things are done correctly. We even include floor plan examples and safety frequently asked questions.
And one of the things I'll do real quickly is I will show you the website where you can purchase the book right here through ITEEA if you haven't seen it. And that link was included on the PowerPoint slide. If you go to read more, it'll bring up the book link down here, which will bring up this site. It has some reviews of the book. It also has, if you click on what's in the book, it'll give you a quick overview of it, which we just gave you, and then the free preview will actually give you, you can click on table of contents, and it'll show you the entire table of contents so you can see exactly what's in it. And there's a page from each one of these chapters that you can preview. And our contact information is on there, and then the link directly to ITEEA to purchase it. So that's a resource that you can use if you're interested in the book and you really want to see it before you purchase it. That's a good resource to use. So what is we'll start with the Fab Lab. When we look at these facilities, a Fab Lab, we're going to start with a Fab Lab because it was one of the first facilities if you look at Fab Labs, Makerspaces, and STEM Labs. But what exactly is a Fab Lab? Well, it's more of almost like an industrial or prototyping platform that's used to spur local entrepreneurship in communities. It's all about the global network. So the Fab network and this community of Fab makers and entrepreneurs. That's one of the big components of this. In terms of laser cutters, laser cutters, 3D printers, sometimes welding equipment. So it's a lot of high-tech, large equipment normally. And then there's some examples. CNC milling machines are another example. So it's a makerspace then. Well, a makerspace is a fun space where people have the opportunity to it combines T&E, family consumer science, art, and science classes. So it's really a huge amalgam of all these different content areas coming together. In a makerspace, it's a Fab Lab, so you could have textiles, students making smart clothing with electronic sensors and LEDs, which would include things such as sewing machines and electronics and soldering. You could also have 3D printers, just a whole bunch of different technologies in a makerspace. It's usually smaller equipment. In a Fab Lab, you'll see more industrial-sized things most of the time. Usually a makerspace is going to be a little bit smaller equipment, smaller area. And again, this is focused on the community learning aspect. So the whole maker community and sharing ideas and sharing different designs through the maker community is a big aspect of this. So not just having a space, but having that community of makers is really what makes the makerspace. And there's going to be various locations, like we talk about libraries or media centers, classrooms turned into makerspaces, or laboratory areas. And what's a STEM lab? Well, a STEM lab relies on integrated connections. So just like we talked about the term integrative STEM education, it's really the intentional integration of science, technology, engineering, and math. And it could appear like a laboratory, like your traditional laboratories. We're going to show you some examples here a little bit later that show a science laboratory area and then also a fabrication laboratory area in the same facility. The teachers with the science education department and the technology and engineering education department use on various occasions. So these are, this starts to get a little tricky when you get into classroom laboratory hybrid designs, where you have a laboratory space and then also it can act as, when you have a classroom space, it can act as a laboratory space as well. And so you can understand, just imagine the safety hazards that might be involved when you're mixing those two areas. So STEM is really, sorry, this is Ken. Go ahead, Ken.
Okay, Tyler. Yeah, STEM, a STEM lab is just not your average math, English, foreign language classroom. STEM lab, again, can be a dangerous place. And when you think about all the possibilities, you're dealing with hand tools, you're dealing with power tools, you're dealing with chemicals, and much, much more. And unfortunately, teachers are sometimes not taught or not advised or unaware of what those hazards are. You can even see in a few of these photographs that are shown, there are some faux pas here, things where people are really not prepared. For example, you have a left-hand corner, not everybody has safety glasses on, and yet they're sawing. Well, what happens if a piece of wood fiber shoots up into the air, gets in the eye, somebody gets hurt? Who's it besides the student who could potentially go blind? The teacher in the school district certainly could be it. So most certainly we need to look at all those aspects, and we need to look at them before the activity is done. We need to determine, once we know those hazards, what the risks are, and then ultimately what are the safety actions that need to be taken in place. It all comes down for the teacher in the school district to something called the duty or standard of care. That's the legal phrase. I do a lot of expert witness work. I'm the guy that you probably don't want to show up in your court case. I'm going to tell you exactly what should have been done and what was not done, and also if the teacher and or the school were considered reckless. And unfortunately, more often than not, the teacher and the school district, in fact, are reckless. Well, how can you protect yourself as a teacher or instructor and also the school? Well, we made a list here under duty of care. Now, what's the duty or responsibility to take care of someone or something? In this particular case, first of all, there's the duty to notify of safety practices and procedures. How do you make students aware of exactly what are the expectations for them when they're in that lab, in that space where all these hazards are? You have a duty, a legal responsibility to let them know exactly what the precautions that need to be taken, what procedures must be followed. You need not only tell them, but you also need to model them. Believe it or not, you should show students how to wear safety glasses and or goggles appropriately. And it doesn't matter if they've had it, if they are juniors, for example, and for 10 years they've been wearing them. It's still your responsibility when they start that course or activity to review exactly and to actually model it, show them how to put it on appropriately. It's also your duty to warn them. What are the hazards? This is a warning. You need to know. For example, you need to make sure that you have closed-toed shoes on, not flip-flops. You must warn them of that. And the other thing is you have the duty to inspect. In other words, as the activities are going on, you have a responsibility to actively move around the instructional site to make sure that things are done in a safe way. And you also have that other duty to enforce using progressive discipline. If they're not following through, for example, if they do not have their goggles on or their glasses or they're wearing them on their forehead, which you often see, the rule basically is you give them one notification. That's it, one warning. After that, out they go. You must do that, because if you don't and they get hurt, believe me, the lawyer in the courtroom for the parent is going to have every one of your students up there in the witness box saying, gee, you know, the teacher didn't do anything when so-and-so didn't have their glasses on or their goggles. So again, it comes down to the liability of safety. Very important. Here are some applications. In the lower left-hand corner, you see a number of students working with meter sticks. Notice, no eye protection. Having taught physics again for about 35 years, from time to time, though it was not intentional, would pick up a meter stick, which is kind of like a lever system. They hold it at one end, and you swing it around, and boom, you can get it right in the eye. Well, hopefully they have on the eye protection, and they won't get hurt. Look at the close quarters. Look how close all these kids are working. The chances of this are really good that somebody's going to get it in the eye. If you look at the center at the bottom, you can see safety glasses. The ports are open. So if you were using this to protect a student from a chemical splash, that liquid is going to go right through those holes. Those holes should not be there. Their caps are gone. You should pull that out of service. The lower right-hand corner, an eye wash station. Well, good luck in an emergency to get to that eye wash station, because you're either going to get impaled or you're going to get knocked in the head by the fan and all that other equipment. You must have 3-foot clearance on all eye wash and showers. On the upper right-hand corner, this was a case in Florida several decades ago. Can you imagine? The occupancy load in that classroom was far, far surpassed. If something happened, if there was an explosion, a fire, can you imagine a kid or even an adult trying to get out of that room? Absolutely impossible. And the last one, the upper left-hand corner, you'll notice, well, the student right up front has the appropriate eye protection on, but look in the background. The teacher and the student, nothing. All right? Tremendous, tremendous legal responsibility here relative to duty or standard of care. So the objective is a safer STEM activity. Potential safety hazards. I always say you've got to drive home safety, AAA. Well, what does that AAA mean? I'm not talking about the American Automobile Association. What I'm talking about is A for analyze the potential hazards. What are the hazards? If I'm dealing with a flammable, all right, what are the hazards? Obviously, the hazards are heat, fire, etc. The second A is assess. Assess the risks of the hazards. Well, what are the risks? Well, obviously, if they're heat and fire, you can get burned. That's a hazard. That's something, a tremendous risk that ultimately would ensue. And what is the action, which is the third A, that you need to address? That is what safety action needs to be taken. In other words, maybe you need a safety shield. Maybe you need heat-resistant gloves. There's all sorts of things. So before you start any activity, you have an absolute responsibility, be it a STEM lab, Fab Lab, Makerspace, no matter what it is, you have to do the 3A approach. Organizations that help reduce the chance of a safety incident, you need to be very well organized. There's no two ways about it. Plan. You need to plan ahead for a safer learning environment. And to be aware of safety, legal standards, better professional practices, and liability.
And I'll add in the book, the Makerspace book that Ken and I wrote, there is a checklist in the back that has some of the components of the 3As, and it helps teachers or administrators kind of analyze and assess an activity before they go ahead and put in action within the Makerspace, Fab Lab, or STEM Lab.
STEM legal standards, there are several either federal, state, or local governmental agencies that deal with legal standards. In the case of OSHA, most but not all schools are directly under either a federal or a state OSHA. The legal safety standards for teachers, the first one is OSHA 29 CFR. CFR is Code of Federal Regulations. 1910 is general industry. School districts, in fact, believe it or not, are in the same category as pharmaceutical companies, computer companies, you name it. 1200 is the Hazard Communication Program. This is the right to understand. It used to be called the right to know, but as of several years ago, that was changed. The other one that's under OSHA is the OSHA 29 CFR 1910.1450, the occupational exposure to hazardous chemicals in laboratories. This is also known as the laboratory standard. Though there are other kinds of legal standards put out there by OSHA to protect employees, these are the two heavyweights. You also see, certainly, if dealing with biologicals, there are bloodborne pathogen standard. There's guarding. There's all sorts of things, but these are the two heavyweights that are in there, and you need to be aware of them. You should receive training on these by your employer. And one last thing I want to mention, OSHA does not cover students. OSHA covers employees. That would be you as the participants here, the teacher, the classroom teacher. It could be potentially a special ed paraprofessional, even custodian. It doesn't matter. If you're an employee in your school district, you are covered under these standards, and you need to be familiar with it through training by your employer.
So there's 3 elements of STEM safety, 3 big elements. And these control teacher student exposure to biological, chemical, and physical hazards that may be present. The first one is engineering controls. This could be anything from fire extinguisher to electrical outlet. It could also even be a guard on a blade. Those are all engineering controls. Preferably, you want the engineering controls to be right at the source. So, for example, if you're using dust collection, if possible, you'd like to collect as much dust right at the source where it's happening. So if you have a downdraft table for sanding, that would be collecting the dust at the source. There's still going to be particles that may float in the air, and that's where an electrostatic air filter would help, but you're helping to limit the amount that's going to float in the air by eliminating it right at the source. Second one is administrative controls. So these would be your work practices, establishing that legal safety paper trail, things such as safety tests and forms, acknowledgement forms that parents and students sign. Those would be administrative controls, as well as classroom management procedures. And then the third one is personal protective equipment, and that's pretty self-explanatory. PPE would be things like safety glasses, safety goggles, gloves, et cetera, et cetera. So all those are needed for the 3 elements of safety.
Again, relative to the planning process, remember, whatever is done, you're going to live with it for a very long time. So this is so key to have the involvement of the classroom teacher or instructor through all phases of this process. Well, what are those things that you need to take a look at in the planning process? You need to consider engineering controls. Do I have the appropriate ventilation, for example? Do I have master electrical shutoffs? Do I have appropriate fire extinguishers? If there are flammables in that room, you're required to have fire extinguishers, right? So there's a number of things. Personal protective equipment. You may need both safety glasses and goggles. What kinds of gloves do you need? There are various types of gloves. Aprons, lab coats, et cetera, et cetera. What about occupancy load? In other words, how many occupants? I'm not talking about class size per se. I'm talking about the total number of occupants that legally are allowed. I'm sure many of you've been to a gymnasium, auditorium, and there's this big sign up in the front that says, per order of your state fire marshal, only, for example, 500 occupants are allowed. The same thing applies to laboratories, be they Makerspaces, Fab Labs, etc. All of those have certain loads that allow. Who decides that? That's the local fire marshal, the authority of local jurisdiction. There's also ADA and ITEEA standards that need to be taken a look at. Programming phase, educational specs. Teaching needs to be involved in ed specs, align the facility with the curriculum. Absolutely critical. And you want to do that near the beginning of the phase. Is that facility going to meet the needs of your curriculum? And don't only think of the curriculum today. There's also the curriculum tomorrow. Are you going to need certain other kinds of, for example, engineering controls? Maybe you're going to need a fume hood of some type, whatever. Visitation phase, get out, see other school districts, what they've done. And I would absolutely urge you not to go to a school district that's only brand new, that just started. Go to a place that has had use of it under their belt for several years. You don't want one 10, 20 years, it's too old, but you want one at least maybe 2 or 3 years old. Get out and visit, see what works, what doesn't work. And also in the plan phase, committee of stakeholders. This should involve architects, designers, engineers, administrators, instructors, school facilities managers, nearby college faculty, etc. So this is this is not going to be done overnight, all right? But you need to be involved right from the beginning to end. Absolutely critical. New construction renovation phase. Communication during the change order. There's something called a change order. In other words, if you walk through, and which I would absolutely urge you get the permission to do, the appropriate supervision, of course, with your hard hat and safety glasses or goggles, whichever the case. If you see things that aren't the way they should be, you need to speak up. And sometimes this leads to what we call a change order. In other words, it's a change in the plan. Again, get it done early so it would be done. Where will instruction be performed during this phase? If, in fact, this is a renovation, for example, you need to plan to have instruction elsewhere. Is that alternate site that you are going to have the instruction, does it meet the engineering control needs, the PPE, personal protective equipment, and the like? Does it have the proper safety controls? So all these things are important to be thought about ahead of time. And final inspection, the school just can't occupy it. What happens is, usually in most school districts, it's both the fire marshal and the building code officials, code administrators that have to approve it to receive what's known as the CO, or the Certificate of Occupancy.
So there's a couple different spaces or instructional areas that could appear in Makerspace or STEM Lab. And in the book, we have a chart. It has a list of the area, the room name, the square footage, and it also has a list of equipment and different safety features that you want to consider putting in there. Again, your space is going to be unique to the curriculum that your school is using and the different needs that your school system has, but we provide some recommendations that you can choose from. So one area is classroom or research design area. This would be where students can go in and use computers and use things like AutoCAD, Google SketchUp, etc., and design. Could be a lecture area, and according to OSHA, it's 25 square feet per student. And then in a laboratory fabrication area, OSHA says you need 50 square feet per student. So you want to make sure that you have twice as much room for laboratory fabrication area because of the amount of equipment that's going to be in there and the amount of room that you would need for students to evacuate safely. And the laboratory fabrication area would include anywhere that lab activities are going to be done. If you have a classroom lab hybrid design, if you have laboratory equipment in there, it's going to be considered as a laboratory. So if you're using it as a classroom instructional space, but you have lab equipment in there, it's going to need the 50 square feet per student. You could have foundry, metalworking, soldering, or casting areas. Some of the Fab Labs have some of those specific metalworking processing areas. And then also in the Makerspaces, you see a lot of the soldering for electronic components. You might need a teacher office or a shared workroom. This could be for faculty where they can, if you have multiple faculty using that facility, a teacher office or shared workroom is always nice so that they have room to plan and a place to put their stuff and also do various things that don't need to be out open in front of the students, such as grading or different things like that. Some equipment and material storage areas. So between 150 and 250 square feet. This is basically just an area where you store your tools, any equipment, materials that you might need. And in the book, we give suggestions about proper storage of different materials, including chemicals, and then also different racks and types of items that you would use to store materials. if you're going to have this area, the material storage area, so that students can access it, then you need to have the tool cabinets and the equipment cabinets need to be able to be locked up. So that way it's to prevent theft and also to prevent hazardous equipment from being used without proper instruction ahead of time.
You know, Tyler, could I also interject on that slide for a minute? People need to understand, I'm often asked this, is this a recommended square footage for occupancy loads, or is this a legal standard? Actually, if you look under the fire codes, the NFPA fire codes that your state has adopted, and also the building codes, and there could be several sources for the building codes, they, in concert with OSHA, certainly established the legal standard. This is not even better professional practice. This is legal standard. It's not optional, and sometimes administrators are unaware of that, and you might need to help them have a better understanding of that.
Some others included in Makerspace or Fab Lab. If you're going to be using chemicals, a chemical storage area, and we talk in the book about the lip that should be on shelves and the fume hoods that should go in the chemical storage area for preparation of chemicals. That's all in there. Project storage area, place where storage is one of the first areas to usually get cut in the planning of a facility, but storage is critically needed, especially for projects. If you're doing a lot of work with materials, you need a large space for that as well. So having that, in the book we also talk about alternative ways to address some of the project storage, such as lockers or cubicles. Those are some ways that you can address that need as well if you don't have the square footage. Finishing area, I know this is one that some people have asked, are we still doing a lot of spray painting and things like that, using epoxies and resins for different things? But a finishing area is certainly something to consider if you are using those processes, and it should include a fume hood, among other fire safety hazard equipment. And then outdoor work areas. So if you're going to be doing things such as hydroponics or things with biotechnology or agriculture or even a greenhouse, outdoor work area would be a good spot to include for students to do that type of work and not cross-contaminate it into a classroom. So the next couple of slides, we're going to go over some examples of some makerspaces and Fab Labs and STEM Labs, which we found to be helpful when we were writing the book, and these are included in the book. This was an elementary makerspace in Texas, and this is one I think is a library. There's a couple, it's a nice space, but there's a couple problems with it. It's organized, which is nice, but the things that are on the shelving are completely open for students to grab and take away. And I've seen a number of companies selling these makerspace carts that you can purchase, and I haven't seen a whole lot of makerspace carts that are able to be locked up. And so what that does is that creates a little bit of an issue in terms of safety, because students now have access to all that at any time with or without instructor permission, essentially. So if this is in a room by itself where it's locked up and it's a identified makerspace room, that's one thing. But if it's out in the general library area, then that could pose some potential safety hazards and obviously some liability for the instructor or the librarian. This is an example from the book in chapter 12. We give some examples of floor plans, and these are ones that we drew up. They're not to scale, but they give an idea of maybe a layout for a lab. We have examples in there for makerspaces, Fab Labs, and STEM Labs, and we chose this one because it was small enough to fit on one slide. The Fab Lab and STEM Lab floor plans are pretty big. They actually span 2 pages in the book. But this one is an elementary STEM hybrid classroom laboratory. So you'll see in here there's a space where students can sit and work. There's movable chairs and desks so the instructor can move those around to clear out room for more activities in the reading area. There's lockable tool and storage cabinets. You'll see there's coat racks and cubicles for students to put their stuff when they come in, so it's not a trip fall hazard. Also, right when you come in, there's a safety glasses or goggles cabinet. You also see a portable air compressed cart for things like if they're doing straw rockets, different activities like that. And then there's also in the back a hand crank drill station. And if you read the article by Kim Weaver from the May 2017 Safety Spotlight and the Technology and Engineering Teacher, she talks about her experience in an elementary STEM classroom and some of these items. But you can see the middle area is more of a instructional classroom space with the overhead outlets. That's what the GFIC signifies. And then on the perimeter is where a lot of the hazardous tools and equipment are stored. So you're trying to isolate some of those hazardous activities to the outer fringe of the classroom.
The next few slides basically are some other examples of elementary middle school makerspaces, complements of the Moats Consulting Group. And again, I want to reiterate what Tyler mentioned, and this is safety and security. Remember, under duty of care, you want to make sure that it is not only safer, but also that it is secure. And in these designs, which you will see, in each particular case is designed in such a way that you can actually secure it, you can lock it. OSHA looks at this when we talk about security. It's just like a boiler room. It's like an electrical room or electrical closet. They consider laboratories dangerous places, so therefore they must be secured. Unless you have adult supervision in these areas, you're looking for trouble legally. You never want to allow student access, let a student even in there without adult supervision. If you look at these designs, again, they really kind of take that into consideration. There's also, you'll notice on the floor plan, there's a lot of space to do different kinds of projects, to move around. Again, it's different. And remember the place, again, I showed you that one in Florida where these chairs are just one on top of another. No, you need space. This is why, in fact, that they have occupancy load codes. The reason, if you look compared to a regular classroom is 20 square feet. In a lab, it's 50 square feet per occupant. Why? Because, again, if there's a problem, you want everybody to be able to get out alive or so they're not injured. And in these particular pictures, these designs, they are designed in that way. And the high school one, courtesy of the Moats Consulting Group, they deal in the design of these things. And again, these are in the book. Again, lots of space, lots of room, different kinds of projects, different small projects, big projects. You've got the safety stuff in there. You've got the GFIs. You've got the storage and cabinets. One thing I would absolutely insist upon, and if you're designing these, is to make sure that the cabinets can also be secured. In other words, that there are locks that are on there, and that would prevent a student from entering, or while your back is turned, to be able to get in there.
Right. Ken, I know one other thing I'd like to add is the Mods Consulting Group normally recommends that cabinets don't have glass in them. So, you know, the glass looks nice and it's easy to see what's in there, but I know they say the glass is more expensive, and so if you have just wooden cabinets, it's less distracting, it's cheaper, and you can put labels on the cabinets to signify what's in there. They're also safer if a student were to fall into one of them and break the glass. So that's a recommendation that they have. This is a Makerspace cart that a teacher named Patrick Dempsey, not the actor, but he's a school principal, St. Louis, Missouri, and he's done a number of presentations throughout the country on makerspaces in schools, and this is a cart that he and his students made. One of the nice things that you can see about this, what I was talking about earlier, is that you can close the doors of the cart and you can lock it up and secure it. So you can see all the different tools that are in there. You have everything from sewing machines to small saws to wrenches to wire strippers to different glues. So there's a whole bunch of different hazards involved in this. And this also brings up another issue with, you can wheel this around to different classrooms, which is nice, so you have a mobile makerspace to take to different places, but you need to make sure that people using these materials and equipment are properly trained to do so.
Absolutely. Good. I've learned a lot.
And then the Library Media Center Makerspace, Laura Fleming has done a lot of work with this. She's out of New Jersey, New Milford Schools. And this is an article she wrote with some recommendations. So that's also cited in the book. This is a makerspace in Lee Hall in Virginia Tech. And you can see they have a 3D printer, CNC, laser engraver, and they have a small space where students can go and work. If you're looking to do an informal type of makerspace, whether it's in a residential hall or a library, this is a nice example. The Fab Lab at the Foundery in Baltimore is another example. You can see there is a textiles lab. You can see there's a 3D printing lab, and then you can see there's a metals area. And so that's kind of, I like this lab space, this area, because it really signifies the broad variety of different hazards that you could find in a Fab Lab or makerspace. And this is from Catholic University, their Architectural Studies program, and it's called the Crough Center out of Washington, D.C. This has 3D printer lab. They have a photo studio. They have a vinyl cutter there, as well as another 3D printer. They have a they call it a wood shop, but what we would call a fabrication lab there with all the dust collection. There's also a mobile Fab Lab, which is an intermediate unit out in near Pittsburgh, Pennsylvania has, and they take this essentially trailer around to schools and they set equipment in the schools for a STEM day. And so they have determined that this was more reasonable than trying to put all this into each single school. So they got a grant, and now they take this trailer around, and they have all the equipment brought right to the school, and they limit some of their liability in doing that. And the last example we'll show, remember we talked about STEM labs being kind of the most extensive in terms of safety and different safety hazards. This is from the old, what used to be a construction lab at Virginia Tech, and they turned it into a really, really up-to-date, modern STEM lab. And so in the front, and these plans, all this is in the book, all these plans. In the front here, you have an area that is an area for more science activities and also design and research. You can see there's computers and 3D printer, and there's the gas hookups in the front, and as well as on the side there by the cabinets. You also have the autoclave, a refrigerator for biological components. And then you have the laminar flow there as well for tissue culturing and other activities. This is just another look at that main area. And then as you go into the back, those glass doors actually close. And so this is a completely closed off area that can be opened up, which serves as a fabrication area. And you can see all the different power tools and fabrication equipment in here. So they can isolate this area, or they can open it up if they have people certified to use it. So some resources, describe these resources.
Yeah, there are a number of resources. These are by the National Science Teachers Association. These are 3 books that I wrote several years ago. They are available in e-format, and they really dwell upon a lot of the legal safety standards, better professional practices, as they apply not only to science labs, but of course also to these other types of laboratories that we've been talking about this afternoon. This is a book that I co-authored with Dr. Linda Stroud about a year ago, and again, this is available on stapress.org, and this is about a 500-page safety manual. Again, there's a lot of applications to the types of laboratories that we're talking about today. Big emphasis, again, legal safety standards, better professional practices. It's very important also if you are a chemical hygiene officer. In other words, you're responsible for the use of chemicals in laboratories, overseeing their appropriate use based on the laboratory standard. Remember, the OSHA laboratory standards requires the employer to appoint a chemical hygiene officer. Doesn't matter if they're in a STEM lab, doesn't matter if they're in a Fab Lab, a Makerspace, a formal science lab, they all must have these chemical hygiene officers to oversee it. And this book is a priceless resource for that. These are additional free resources that are available. We have the safety portal at NSTA. I would absolutely urge everybody in this webinar today to at least go take a look. A lot of legal safety standards, better professional practice information there. On the commercial end, they have the Flynn Scientific. They are very well known. I would absolutely urge you to request one of their catalogs. It's also a safety manual. It tells you if you're going to be using any kind of chemicals, how you appropriately use it, how you appropriately store it, and even more importantly, how you appropriately dispose of it. Sometimes you buy these chemicals and you might pay maybe $20 for a pound, or about 500 grams, we'll say, and to get rid of it, it costs you $2,000. You don't have to do that. You want to look ahead, so that's a good resource. NSTA Safety Blog, I mentioned before, an outstanding resource is the Maryland Online Science Manual. A lot of really good types of information there. Again, I want to say it's applicable not just to the science labs, but also to these other areas we talked about today.
And here's some of the resources. This is the NSTA Safety Portal. You can see there's a number of position statements already posted on there. It could be applicable to both tech and engineering and science laboratories. There's a safety blog that Dr. Roy does, and there's some items on here that would be of interest, like requirements for eye wash showers and stations. There's are there 3D printers that got some attention recently. And then this is the Maryland Science School Improvement. And like Dr. Roy said, this is a very useful resource, and our book has some similar information, but also updated information. Resources from a tech ed standpoint, the ITEEA Safety Resource website, which I'm sure most of you are familiar with. This was from the 2014 book, so this goes along with that and has safety tests and videos and PowerPoints. Also, Virginia Tech has a really good website for laboratory safety resources with tests. And then the articles which ITEEA has been publishing over the past year has a number of relevant topics and on safety. The ITEEA Council for State Leaders has some safety information on it as well, a dedicated safety website with videos. Pennsylvania Department of Education has a pretty good safety document. So all those are good tech and engineering ed resources. Most of them are free. So I guess before we get to the questions, one thing I will say is people have asked us, what is the difference between the 2014 ITEEA safety book and this new safety book that we've done? And I just want to clarify that the new safety book is not meant to be a replacement, but really is meant to complement the 2014 ITEEA safety book. And I think when you look at the table of contents, you'll see that there's some things that are similar, but there's also a lot of things in the two books that are different. Like this new book does not have the safety test, but it does have more of the floor plans and the types of areas and square footage that you would want. So I would recommend both books for a school laboratory or a department. So if there's any questions, Dr. Roy and I would be more than happy to answer your questions.
So this is Jenny, and I'm reading some questions from the chat, and I'll try and keep an eye on those. So if anyone has questions along the way, if these conversations bring up more, then please do put them in the chat, and I will make sure that they're read and discussed. And also for those of you who are new to WebEx chat, make sure there's a little drop down next to where you type your question or your comment. Make sure that in that drop down you select that the message goes out to everyone. Otherwise, by default, it might just go to one person. So the first question for you, how is class size or occupancy load determined for a lab? What's an appropriate class size, and what if the school places too many students in the class in spite of a teacher's request, which we know happens quite a lot?
Can you go ahead and start that one? I know you've gotten that question a lot in the past.
Yeah, which again, this is based primarily on the fire code and the building code. And as a rule of thumb, if you look at the NFPA 101 Life Safety Code standards, it talks about occupancy load in laboratories. It talks about them in shops, etc. So that covers the waterfront. And basically the bottom line is 50 square feet per occupant, but that's net. And by net, they mean you have to subtract out counters, desktops, tables, etc. So you do the length times the width and you subtract that out and you divide it by 50, and that tells you approximately what the occupancy load should be. Now, having said that, to get your certificate of occupancy, your local or state fire marshal had to approve that, and in doing so, they had to approve the occupancy load. So usually you can find out what the occupancy load is by looking on the architectural prints. 99% of the time, not always, but 99% of the time I say it's right on there. So that's the first place I would go to look for occupancy load. And on the other end of the spectrum, if you're unsure about it, you ultimately talk to your administrator, and you might want to have the fire marshal come in just to take a look and determine exactly what the occupancy load is. Remember, the fire marshal is the authority of local jurisdiction. Whatever he or she says is the law. That is what it would be for the occupancy load.
I'm not sure if I'm allowed to give a question over the audio.
Sure, go for it.
This is Joseph Woodard in Utah. My question goes back to the meter sticks where the kids didn't have safety glasses. Those of us in a technology or science background that have been aware of safety for a long time, we see that. But how do you explain to the teacher next door who's never had to deal with safety glasses because their things are very simple, like, you know, a meter stick, that we're going to use safety glasses in my room when we have that same activity, and they don't? How do you broach that with people whose activities are really not that dangerous?
This is why your employer is required to provide safety training when someone is hired initially, and also when there are changes in the environment. There are other kinds of hazards. People sometimes say, well, you know, I'm using a meter stick. That's really pretty safe. It is until you either your eye gets impaled by it. This is why I'm saying you need to go through that. What I do is I also work with people to go through that AAA process, all right? You need to take a look, what are the hazards? You now analyze what the hazards are. As a result of those hazards, you need to assess what are the risks, all right? What's the hazard? Well, if it's a lever, potentially could get impaled. So the risk is, yeah, you could lose your sight, absolutely. So what do? What's the safety action? The safety action is, well, you need eye protection, all right? So that's how I would kind of work with that person. That technically, in part, is your kind of responsibility, but it's really legally the responsibility of your employer and that person's supervisor.
Thank you.
So we have a question in the chat. Wait, let me scroll back. How often should pre-K through 12 STEM involved teachers go through formal safety training and updates through workshops like yours? There's from companies like Flynn Scientific. Generally speaking, and I'd like to just add on to that, what sort of data exists on the current standards for that sort of thing? How often do teachers actually go through training? Maybe not just how often should they, but how often do they go through safety training?
Yes, Dr. Roy. Okay, it's been my experience, and I've done a lot of safety training over the years, and it's scary, to say the least. And I find that most of this happens, my awareness of it is my expert witness work. I found situations where teachers either have never been trained or it was 10 years ago they were trained. Just sad. And again, OSHA requires that the employer provide safety training for the laboratory standard, for HAZCOM, for all these other standards. There's safety training required. Well, when are you supposed to have that safety training? Initial employment or initial assignment. Maybe you've been in a particular situation, teaching a particular course, and now you've had a change in schedule. You're going to teach a new course that you never taught before. That requires potentially, if the hazards are different, then you need to have training again. So again, once just before or just at the initially starting a new assignment, you're required to have that training. Well, how often after that? Well, to be honest with you, the best thing to do is have an annual safety training. What are the instances that came up during the past year, things? What are the changes? Maybe you have new chemicals you're dealing with. Maybe you have new power tools that you're dealing with. Things change. Safety is not static, all right? It changes constantly, and you need to be on top of that. And this is why OSHA says that the training needs to be ongoing, but you want to make sure that initially, and unfortunately, I hate to say this, but this is where not all, but many of the universities fall flat on their face. I couldn't tell how many student teachers I have had that the students have had no safety training whatsoever. And that responsibility falls, therefore, on the school district. Well, sometimes the school district doesn't follow through, and it doesn't happen. The safety training doesn't happen until there's an accident and the school district gets sued along with the teacher. No, that's too late, way too late. So again, the safety training should never stop in effect. It needs to be ongoing.
Jenny, you asked about research. Really, that the research on in terms of safety is related to occupancy load, which I know is a different topic, but Sandra West did a study, I think it was in 2002, but it's still cited throughout the science literature, and it says that for 24 students in a laboratory area, and these are, not counting students with special needs or students that require additional attention, but 24 students for one teacher. As soon as you go above 24 students for one teacher, the rate of accidents increases at a statistically significant rate. So I know that is on the NSTA safety portal, and that has been used a number of times in different, most recently in Virginia, they tried to pass legislation limiting the number of students in a laboratory area, and they used that research.
Let me Dr. Roy, let me just add one thing. This is providing that the occupancy load is not surpassed. In other words, when they say you have 24 students, well, that's fine as long as the lab is designed occupancy load-wise to hold that number plus the teacher, of course. But if your lab is designed to hold maybe 16, 18, 20, whatever, you can't have the 24 in there, even though that might be a good number to have. It also is based on the occupancy load.
Good point. Thank you for clarifying that.
So we have a question about liability. What is the liability or associated risk involved with teachers designing and developing a makerspace or a lab? We know people have these ideas. Sometimes they have funding to put a lab space together. Is there anything else on the liability front that you want to add to that?
I think that the liability for teachers should be limited because they should be working with the architects or the facilities management staff at their school. They should also be working with the OSHA specialists at their school. Whoever's in charge of facilities, if they're making significant modifications to the facility, then they should be working with those individuals within their school system. And those individuals will know the OSHA standards and do a check for the safety engineering controls. So that should help limit their liability. Ken, do you have anything you want to add?
Yeah, the other thing, the saving grace, so to speak, is that CO, the Certificate of Occupancy, because what's happened is the building person and the fire marshal have to sign off. It's very important for a school not to allow any instruction to take place in that new site until they have that Certificate of Occupancy, because basically that kind of releases you from liability, because when they come in and they look it over, they're saying, okay, this meets the standard, there's no problem. So if a teacher had designed that in, even though that probably would have been caught long before, that is your saving grace. However, once you have a certificate of occupancy, if a teacher decides, oh, I'm going to redesign this, I'm going to change this, I'm going to make some other physical changes in there that may not be legal or meet that legal safety standard, then there is liability for that teacher and also for the school district.
And how long do safety tests and documentation need to be kept on file with the teacher or with the school?
There are different amounts of time that are used. For example, believe it or not, and this is not necessarily a piece of the building or design, but for example, the current safety data sheets or material, we used to call them material safety data sheets until several years ago, but the current safety data sheets, you have to keep those for over 30 years. That's a requirement by OSHA, 30 years. Well, why is that? That's because if you retire and you develop COPD, your lawyer needs to be able to go back to that school district and look to the kinds of chemicals supposedly that you might have been exposed. So when we're looking for that type of thing, it really depends on the kinds of things that you're looking at. If you're looking at a safety acknowledgement form, like the old safety contracts we used to call them, if there's an accident, well, you better hold on to that for a few years at least, just to make sure in case you get sued. You need to have that because that will be quite helpful in your defense. So it depends on what piece of the safety that you're talking about in the facility or the operation of that facility that dictates the amount of time that you're required to hold on to the stuff.
Another question from the chat. As you add new projects, how do you find the safety requirements? Specifically, as we expand our electrical projects, where would I find the specific safety requirements for that? I'm asking because we have just created a lab space in an empty room and going from basic cardboard projects to robotics and electrical circuits without big equipment. We do use safety glasses. So they have a good start. So where can people go to find as they upgrade their programs?
Buy the book. Seriously, that would be really helpful. Tyler and I have, between the two of us, many years of experience in dealing with safety, the legal, the better professional practice, both of which, by the way, in a courtroom are now of equal standing, and that's very important. Belonging to organizations like ITEEA and other organizations, that keeps you really on the cusp of things here, so you know any changes that are taking place. Follow my Twitter account. That has all the latest stuff on legal things that I find out and put right out there for people. Blogs, go to these safety blogs. Again, that's extremely helpful. There's a tremendous amount of resources. And in fact, what I find sometimes, and this is a really appropriate question in some of my expert witness work, teacher never bothered looking to see, never bothered going into listservs, for example, to find out, well, what other experience have my colleagues had in doing this type of thing? Didn't bother doing that. And let me tell you, in a court of law, that's a professional expectation of the teacher to do that before. This is part of that hazard analysis that we talked about. So, yeah, there's a lot of possibilities out there. Again, the ITEEA has been really super about providing that stuff, so is the National Science Teachers Association. There's a number of others out there. Get involved. Believe me, it's a small amount of money to pay compared to being in a court case where you got to pay sometimes hundreds of thousands of dollars.
In terms of electrical components, there should be specifications within the manuals of different equipment that you're purchasing, and those should be shared with again, your facilities manager at your school district or the community center, and they should be building in, making sure that you have the proper engineering controls and the proper outlets, and it can handle the voltage of that equipment. So I would definitely work with those individuals and share that information and research that before you purchase those items, to make sure that the lab space, especially if you're going from an empty room, make sure it has all the proper safety and engineering controls included for the activities that are going to be done within that room.
I see a question about the safety testing. Would an electronic safety test, maybe something on Google Forms, be as good as paper tests when it comes to liability?
Yes, as long as you can show that you made every attempt to train and assess the level of understanding of that training relative to safety. It really doesn't matter on the format as long as you're able to produce it.
Are there other questions for the presenters? I think I've been able to go through everyone that's in the chat. Does anybody have anything else they want to ask while we have these gentlemen live with us? Okay, so just one more. As safety experts, what are your thoughts on STEM teachers getting the liability coverage through ITEA's insurance carriers? Let's see, what I can say is the current rate is $99 for $1 million liability limit, $136 for $2 million liability limit, and then there's some add-ons beyond that. Do you guys have thoughts on that? Do you have suggestions? Have you found it valuable?
I always encourage my pre-service teachers, so my student teachers, they're about to go out into the field. I encourage them to purchase the insurance before they get out and start student teaching, and I think it's just a good habit to get into, because when you look at, I think he says $136 divided by 365 days a year, it comes down to, I think, a couple cents per day. In the event that something does happen, I'd rather spend a couple cents a day than be concerned about any potential liability costs. Now that the one thing is you have to read the fine print of those insurance policies, because if there is gross negligence on the teacher's part, you may not be as covered as you think you are. So if you have taken all the proper safety precautions and there is an accident, that insurance policy would certainly be something that you would want. But if you put a student in a harmful situation knowing, say you put them on a piece of equipment knowing that there's a defect with the equipment and they get hurt, you could be found grossly negligent for allowing that to happen. So, that's the one caveat I would say, is that those insurance policies help protect you if you are doing everything that you're supposed to do. It's just because you purchased insurance policy doesn't guarantee that you're going to come out without any liability.
So, two kind of related questions. Can you comment on selecting developmentally appropriate materials and tools for students? so developmentally appropriate, and then also, do you have recommendations for contacting parents early in the year or throughout the year? Does this seem to have an impact on outcomes when there are issues?
Jenny, can you read that question?
Yes, so let me come back over here. So it's kind of two questions at once. Can you comment on selecting developmentally appropriate materials and tools for students? And then also, depending on the ages with which teachers are working, do you feel like reaching out to parents early in the year or throughout the year has a significant impact on outcomes when there is an issue?
Yes, I think the first part of the question is developmentally appropriate. The teacher in the classroom is going to be considered the expert because they should have had training, safety training through their school district or teacher preparation program. If they're using a curriculum that says these are activities that should be involved for this age group, so for example, if they're using EBD curriculum, those materials that are part of that curriculum should be developmentally appropriate. In terms of if you're going to select your own projects, that's a tough question because it may depend on, you may be in a school district where students are really mature and they can handle using things like scroll saws or band saws at the middle school level. You may be in a school system where students have never seen a power tool in their life before they walked into your classroom. So I think it depends on the types of students that you have, not just at your school district, but from class to class, and determining what, in your professional opinion, would be developmentally appropriate. And then the second part of that question, in regards to contacting parents and students, always at the beginning of the year, you want to put the safety expectations out there. Remember that part of the safety acknowledgement form, and there is a safety acknowledgement form included in the book. Part of that process, one of your duties as an instructor is a duty to warn or to put parents on notice about what are some of the hazards that my child may be exposed to in a Makerspace, Fab Lab, or STEM lab. And so at the beginning of the year, you want to make sure there are expectations in terms of classroom management, but also letting the parents and the students know these are potential hazards. And as an instructor, I'm going to do everything I can to make sure it's the safest working area possible. But there still are associated risks. And throughout the year, you want to make sure you're continually doing. We in the book talk about different teaching strategies, and we have things in there called safety cards, where you can have a safety scenario, and you may walk around at any point during the year and hand one to a student, and they have to act out a safety accident. Other students won't know that you've given them a card, but you'd get to see the reaction and how they respond. That's one teaching method that we included in the book, but also, safety should be in your lesson plans, documented. Again, that's just good practice. They should be in departmental meetings discussing any relevant safety topics that come up. Again, you're creating that legal paper trail, that safety paper trail.
Can I just go back and make a comment relative to one of the previous questions, and that was the one about having the liability insurance. Tyler is absolutely correct. If you want to sleep nights, you get that insurance. But one of the things that the instructor or teacher should do is check with their school district that hired them, their employer. Most, if not all, do provide liability insurance for the instructor or teacher. And it'd be a good idea to know exactly the extent of that. Also, what does it cover? If you're determined to be reckless, well, does that mean they're not going to cover you? These are the kinds of things that you need to ask right up front. So I'd say a combination of still having your own, even if the school district has them, but professional liability insurance is absolutely critical.
All right, are there any more questions before we wrap it up for today? All right, well, thank you guys so much. This has been incredibly informative. And yes, and so those of you who attended the session today and those of your colleagues who were signed up to be here, anybody who didn't make it will also receive a WebEx archive email following the end of the meeting, and so that will allow you to go back and review this webinar. I know that there were some links placed throughout. We'll also upload a PDF version of the presentation, and you'll be able to download those files after the webinar concludes. So you'll have access to all the links that were mentioned throughout the presentation, as well as the information about ordering the book if that's what you'd like to do. So thank you, Dr. Roy and Dr. Love, for your time today. It's been fantastic. Thank you, everyone who made the time to be here this afternoon. Have a great afternoon.
Thank you. Those of you that purchased the book, enjoy it.
Yeah, great job.